Section 3.3 deals with division of polynomials. We have two different methods. We're going to look at both of them. You were introduced to both of these last year, so hopefully that will bring back your memories of it. We are going to use long division and synthetic division. We do have to know both of them because long division will always work, but it is long. All right, synthetic division is a shorter, faster method, but it only works sometimes. So we do have to know both. And then we're going to look at evaluating a polynomial using something called the remainder theorem. We won't be doing our last bullet there today. So we are going to start out just reviewing long division. Think back to 4th grade. All right. You had to learn how to do this by hand before you had all your calculators. What was the process we used? You don't remember. Okay. Well, then we're going to pause the recording and I'm going to give you guys a few minutes to talk to each other, see if you can remember what you do. All right, back to our long division problem. We have a very large number, yes? 586,000 something. We're only dividing by a 7. We don't want to try to come up with the whole answer, right? We want to take it in little pieces. So we start out. Does 7 go into 5? No, so then we have to move over one. Does 7 go into 58? Yes. How many times? 8. Okay. Where do we put the 8? Up on the top. Good. All right. Put an 8 on the top. Then what? Then we multiply it, right? 8 times 7 is 56, and we write it underneath. And then we subtract. Guys, you with me? Okay. 58 minus 56? 2. All right, keep going. We bring down the 6, and we repeat the process, right? So 7 goes into 26 3 times. We put the 3 on top. 3 times 7 is 21. We subtract, and we get 5. Then we bring down the 2. All right, how many times does 7 go into 52? All right, 7 times 7 is 49. We subtract. Okay, we bring down the 4. 7 goes into 34. 4 times 7 is 28. We subtract and we get 6. We bring down the 8. And one more time. 7 goes into 68. How many times? 9 times would be 63. We subtract and we have 5. So back in elementary school, right, you would have just put R5, right, remainder 5. Then you learned about decimals, and you put a decimal and added some zeros, and you kept dividing. And you learned about fractions. We're going to take it in a fraction form. So we have 5. It's trying to be divided by 7. So we have 5/7 as the remainder. Okay. The whole reason that we went through just with whole numbers is the process is the same with polynomial long division. Instead of thinking of, ones, tens, hundreds, etc., we have our constants, our x's, our x squareds, our x cubes. We can still divide using that same process. Okay? So our first one here, we have 6x cubed minus 19x squared plus 16x minus 4, and we are trying to divide by x minus 2. The trick to doing polynomial long division is to just worry about the first term. Okay? We're going to take just the 6x cubed, and we're going to divide it by just the x. Okay? If we take 6x cubed and divide by x, what do we get? Okay, the 6x squared is going to go up on top. Okay? And then we need to figure out what to put underneath. So just like on this last problem, we took the 8 times the 7 to get 56. Okay? We are going to take that 6x squared on top. We're going to multiply it to the whole thing. Okay? We use the first term to find that 6x squared, but then we do have to multiply it to all of it. What do we get if we take 6x squared and multiply it to the x minus 2? We get 6x cubed minus 12x squared? Yes? All right. We then have to subtract, and this is the step that usually causes problems. Students do fine on the first column. Your 6x cubed minus 6x cubed is gone. That should always happen. Okay? That first column should always disappear. If it doesn't, you did something wrong. It's the second column that students get mixed up on because they forget they're subtracting. So if you find that you do that a lot, if you make mistakes in this step, then distribute that negative sign. All right, we can make this a negative 6x cubed. We can make that a positive 12x squared, and then we're just adding. Okay? So our x cubes we said are gone. What do we get when we take negative 19x squared and we subtract a negative 12x squared? So we're adding 12x squared to it. Okay, so we have negative 7x squared, and then we bring down our next term. And we just keep repeating that process. So we're going to take the first term, okay, to find the top number, we just take the first piece. What is negative 7x squared if we divide it by x? All right. Then we take negative 7x times the whole thing, times the x minus 2. So negative 7x times x is negative 7x squared. Negative 7x times the negative 2 would be a positive 14x. And then we have to subtract all of that. Do our x squareds disappear? Okay. Now looking at our x's, we have 16 x's and we are subtracting 14 of them. That means we only have 2 x's left. Okay. Then we bring down our last piece, our negative 4. And we repeat this process one more time. Take your 2x, divide it by the x. We get a positive 2. Take the 2 times the whole thing, x minus 2. We get 2x minus 4. And what happens when we subtract? So we have no remainder. Yes? Now, having no remainder is great. It tells you some things about the original problem. If I told you to take 8 and divide it by 4, you would say you get 2. No remainder, right? Because 4 and 2 are factors of 8, right? It divides it evenly. Well, if we do this long division process and get no remainder, what we're saying is that this x minus 2 is a factor of that polynomial. And this top piece, the quotient, is the other factor. So we can use long division to help us do some factoring. Okay? All right. The one thing to notice about our next one here is that our original polynomial is not in standard form. We want it to be. All right? When we go to rewrite this and actually do the division, we got to rearrange these terms. So we are taking a polynomial. We're dividing it by 3x minus 2. This polynomial we're going to rearrange. Which term would go first? Okay, 6x cubed. Then what? Minus an x squared, minus the 5x, and plus the 4. Okay? Now again, focusing just on the first terms. We have a 6x cubed, and we're trying to divide it by a 3x. What are we going to get? Okay, that 2x squared goes up on the top. All right, that's part of my quotient, my answer. 2x squared. How do I get what I put underneath? Okay, so now I have to take that 2x squared and multiply it back to the 3x minus 2. And that gets me what? 2x squared times 3x. 6x cubed. And 2x squared times negative 2. Negative 4x squared. And then what do? We subtract them all. Okay. Does your first column disappear? Good. Second column, we have a negative 1x squared. We're subtracting a negative 4x squared, which means we're really adding 4x squared. So what's negative 1 plus 4? Okay, we get 3x squared. We bring down our negative 5x. Take the first term, 3x squared, divide it by the first term, 3x. What do we get? Okay, that x goes up on top as a positive x. Now we take that x and multiply it to the 3x minus 2. That gives us 3x squared minus 2x. That goes underneath. And then we subtract. All right, what do we end up with? Negative 3x. All right, we bring down our positive 4. And our last time through, what's negative 3x if we divide by 3x? Negative 1. All right, then what? Good. Negative 1 times the 3x minus 2 gives us negative 3x plus 2. All right, last step, we're going to subtract. Does our first column disappear? Okay. Second column, 4 minus 2 is 2. So that is the remainder. How do I know I'm done? Because I can't take 3x out of a plane 2, right? As soon as your degree of your x's becomes smaller than what you're dividing by, so this would be 2x to the 0, I can't take an x to the first out of that. Okay, so then I know I'm done. All right, so remainder is 2. I would write my answer as 2x squared plus x minus 1 plus, now I need to put that little fraction, that's the remainder. I have a 2 that is being divided by what? 3x minus 2. Okay? So, polynomial long division works. It will always work. Okay? Synthetic division only works when what we are trying to divide by is x minus or x plus a number. Okay? So we can use synthetic division, but it can only be used if we are dividing by x minus c, which again you could write it as x plus as well. So x minus a number, x plus a number, we can do synthetically. Okay? What happens with synthetic division is we get rid of all of our variables and powers. Okay? We clean it up. We just deal with the number parts. It is critical when you are doing synthetic division to put in zeros for any missing terms. Because as soon as we take our x's out, we don't remember, was that an x squared or was that an x cubed? All right? If it's not in the right spot, we're not going to know what we're doing. Okay? With polynomial long division, the ones we just did, if you are missing a term, you should still put a 0 in for it because it's going to let your columns line up correctly so you can subtract. All right? So anytime there's a missing term anywhere in there, even if it's the constant, you still need to put a 0 in there for it. Okay? So looking at this one, we have some cubes, we have some x squareds, we have some x's, and we have a constant. So we're not missing any terms. When you do the synthetic process, your division bar is upside down. The top row of numbers here is going to be just the coefficients of all of my terms. So the coefficient of x cubed is a 1. For my x squareds, I have a 4. For my x's, I have a negative 5, and my constant is a positive 5. Make sure you separate those well enough. We want that to look like a 1 and a 4. We don't want it to appear like a 14. Okay, so put a little space between your columns. With polynomial long division, we always had to do that subtraction step. With synthetic division, what we can do is change our sign, and then we can add. So if I'm trying to divide by x minus 3, I'm actually going to put a positive 3 out front. If it helps you to think of it as what makes it 0, right? If you have an x minus 3, 3 would make it 0. That's what's going to go out front. Okay? To do the process, we bring down our first coefficient. In this case, it's a 1. We then multiply these together. So 3 times 1 is 3. And we put that in the next column. Okay? So I multiply the front number to that first 1, and I put my answer there. Then I add the columns straight down. So 4 plus 3 is 7. And then I just keep repeating that process. So I'm going to multiply. 3 times 7 is 21. I'm going to put it in the next column. And then I'm going to add down. Okay? What's 3 times 16? 48. Put that in my next column. And I'm going to add straight down. Okay? Now we have to decipher what these numbers mean. We have to put the variables back in. I want you to think for a minute. If we had done this with long division, we would have been taking an x cubed and dividing it by an x. Yes? What would we have gotten? An x squared. That means the first piece of my answer should be an x squared. This 1 here is my 1x squareds. The 7 would be my x's. The 16 would be my constant. And what is the 53 going to be? The remainder. Okay? So this is my remainder, constant x squared. So my answer would be 1x squared plus 7x plus 16 plus the fraction remainder. 53 was being divided by x minus 3. Is that process coming back to you? Remember doing that last year? Okay. All right, so for the next 3 questions, it says to divide using the best method. You are going to pick, and even in your homework assignment, even if it says divide with long division, if you can do it synthetically, we want you to do that. Synthetic division can only be used if what you're dividing by, your divisor, is x plus or minus a number. Okay, a single x plus minus a number. So can we do the first one synthetically? No. We would need to do this with long division. Okay? Can we do the second one synthetically? Yes. Can we do the third one synthetically? Okay. So I'm going to pause the recording. I want you guys to try the first one here, long division. Watch for missing terms on any of these 3. All right, so for this first one, we have x squared minus 2x. We are dividing it into what? Two x to the 4th plus 3x cubed. What's missing? The x squareds are missing. You need to hold a column for those so that your columns, when you try to subtract, you're subtracting like terms. Okay? If you don't, you're trying to subtract squares from x's. It's not going to work. Okay? Technically, we are missing the constant at the end of our divisor. We have x squared minus 2x plus nothing. With long division like this, if the constant is missing in your divisor, it's okay. We can certainly put a 0 in there to hold its space, but it's not going to really affect our columns. But any terms inside will. And if you're doing synthetic division, and you were missing your constant at the end here, you'd need a 0 there. Okay, there has to be a column for that. All right, so long division, we are taking 2x to the 4th and dividing by x squared. What do we get? 2x to the 4th dividing out x squared. All right, we get 2x squared. Now take 2x squared and multiply it to both of those. So we have 2x to the 4th minus 4x cubes. What do we get when we subtract? Okay, agree, disagree, 7x cubed? Yes? All right. We bring down our placeholder here, the 0x squared. What is 7x cubed if we take out an x squared? 7x. That goes up on top. Now we take 7x times both. We get 7x cubed minus 14x squared. And when we subtract, our x cubes go away. What do we get for x squareds? Okay, positive 14x squareds. We bring down our negative 7x. We have 14x squared, and we're dividing out an x squared. We end up with a positive 14. 14 times that. What do we have left? 21x. And we bring down our negative 10. Can we take an x squared from 21x? No. So we're done. That whole piece now is my remainder. So my answer to this division question would be 2x squared plus 7x plus 14 plus, I have the fraction 21x minus 10. We are dividing by x squared minus 2x. All right, our second question we said we could do synthetically. What are we going to put out front? We're going to use a negative 9. We're trying to divide by x plus 9. We use the opposite sign, negative 9 out here. Do we need any zeros to hold places? No? Okay, so we have 1 for x squared, so we have 14 for x's. We have 45 for a constant. We bring down our 1. Multiplying, we get negative 9. Adding the column, we get 5. Multiplying the negative 9 with the 5 gives us negative 45, and what happens? We have 0, and what is that? That 0 would be the remainder, right? The last number is your remainder. This would be your constant. This would be your x value. So we have no remainder. The answer is simply going to be a 1x plus 5. Now, what does it mean if there's no remainder? That it's a factor. So x plus 9 is a factor of this quadratic. X plus 5 is the other factor. Okay? All right, I am going to pause the recording and let you guys try number 3. Watch for missing terms that need zeros plugged in. All right, let's check our work here. What are we going to put in front if we're dividing by x plus 2? A negative 2, good. Do we have any missing terms? The x squareds. So we have a 5 for our x cubes. We have no x squareds. We have a 6 for x's, and our constant's an 8. Our first number gets brought down. Negative 2 times 5 is negative 10. Adding gives us negative 10. Multiplying, we get 20. Adding, 26. What's negative 2 times 26? And what do we get if we take negative 52 and add 8? Negative 44? Okay, so what is my answer? The 5x squared minus 10x's plus 26 plus a negative 44 over x plus 2. I would get in the habit of always making that a plus sign, because if your remainder has 2 parts to it, like our previous answer had that 21x minus 10, all right, you don't want to just pull out the first sign. It's going to throw the remainder off. So get in the habit of just saying I'm adding this little fraction piece, and if your remainder is negative, leave it negative on top of your fraction. Okay? All right. Our last little piece uses the synthetic process to help us evaluate a function. The remainder theorem says if a polynomial f of x is divided by x minus c, the remainder we get is f of c. Now, what does it mean to say find f of 5? What would you do? If I give you a polynomial and say find f of 5, you'd put a 5 in for all the x's, right? We can do this synthetically. If we want to find f of c, we can use the synthetic process and pretend we're dividing by x minus c. What that means, when we set up our synthetic process here, the number that's going to go out front is actually the same value they're asking you to evaluate for. If they're telling me to find f of 2, it means I'm really dividing by x minus 2. Yes? So in that synthetic process, we would put a plain 2 out front. So the nice thing here is you don't have to change any signs. If it says find f of 5, you put a 5 out front. Are we missing any terms? All right, so coefficients 1, -4, 5, and 3. We bring down the 1 and multiply. 2 times 1 is 2. When we add, we get -2. 2 times -2 is -4. Adding, we get a 1. And 2 times 1 is 2. Adding, we get 5. And the only number I'm concerned about is the remainder, right? It says f of c is going to be the remainder when you synthetically divide by x minus c. So my answer, f of 2, is just the 5. Okay? All right. I'm going to pause the recording. I want you guys to try the last one. All right. Let's check our last one here. We are trying to evaluate for -4. Do we have any missing terms? All right. So 3, 4, -5, and 3. We bring down our 3 and multiply, adding, multiplying, adding, multiplying, and adding. You should have gotten f of -4 being -105. Questions on that process? All right. So for your homework, you're going to do 1 through 16 and 33 to 40. On the 1 through 16, it has divided it into some doing long division, some doing synthetic. I want you guys to make sure you pick the best method and do it that way, even if the directions tell you otherwise. Okay? If it can be done synthetically, do it synthetically.